Hi there, my name is Ovidio Popovicu, and in this video I'll be presenting my fourth year project which was designed and implemented during my studies at University of Glasgow. So, first of all, I'll be going through a simple structure of the video so that it makes more sense later on. Don't worry. Therefore, we'll start off with some background, basically what the purpose of the project is, who's it useful to, and its environment. Second of all, I'll be going through the actual user interface of the project and I'll be showing you how the software works. In the last part of the video, you see me trying to figure out which speaker produced some sound. This should be fun, so let's begin. So, the purpose of this project was to develop an application to aid researchers at the University of Glasgow Computing Science Department in their research for encouraging visually impaired people to interact more with their environment. Research done by Wilson and Brewster have shown that dynamic sounds may provide more accurate feedback when blind people interact with their environment, rather than constant, unchanging feedback. The way they are doing this is by setting up experiments with blind participants while tracking their hand movements, time taken, and changing between different types of feedback. Therefore, this project is built to give a more dynamic, efficient, and comfortable way of gathering data from participants. How does it do this? Basically, the software uses the Intel RealSense camera. This is a new technology from Intel, released in 2014, and is able to perceive that. I found it really awesome to work with, and its API is quite easy to use. The sound will come out of a set of mini body speakers. The camera tracks the position of the speakers by detecting markers placed in front of the camera. In addition, the camera also tracks the movement of the hand and calculates the distance between it and the target speaker. As the hand gets closer to the target speaker, the feedback sound will change according to the distance between them. The experiment is set up on a small table with speakers following a certain position pattern. The camera resides on one side of the table, with the participant sitting on the other side facing the first speaker on the left. In addition, the participant has another speaker attached to his wrist for research purposes. There are three types of designs that are studied in this research. That's constant, Geiger, and pitch. The constant design does not modify its feedback and will remain unchanged. So this is the sound made by the constant one. So it didn't change at all. Now we're going to hear the Geiger counter, which increases the frequency of the playback as the hand gets closer and lowers it when the hand gets further away. So let's see how this sounds. Okay, so that was the Geiger counter. And similarly, the pitch design will increase the note pitch as the hand gets closer and will decrease the pitch when it gets further away. Let's hear that. Just make sure that's the one. Yeah. So you can actually hear the note changing as the hand gets closer. In addition, there are three types of feedback that are used. So the first one is the individual feedback. That's the first sound is output from the target speaker only. So that means that only the speakers on the table are outputting some sound. The second one is the coalescent. That's both the target and the wrist speaker outputting sound at the same time. And lastly is the wrist speaker, which outputs sounds only from the wrist speaker. Cool. So if you want to learn more about the study or about the hardware, you can follow the links over here. Now we're just going to go and see how the software actually works. Hi. So on my desktop just now, I have the actual software running. So this is the first view that appears when the software is running. So let's say we are researchers and we want to start an experiment. So I'm just going to press on New Experiment. Now, in the first window, we see a split screen. So one of them, the left-hand side, is the marker screen, and the right-hand side is the color stream. Now, as the color stream detects markers, it will automatically update the leftmost screen with the marker and its current position in 3D. Now, let's start the tracking. Cool. So we have two markers detected, so that's marker number 2 and marker number 3. But we have a speaker over there. I can see a speaker which is misaligned, so the camera can detect it. Now I'm just going to align this, and the camera should detect all 3 speakers, which is pretty good. Now, if we have no speakers, for example, I'm just going to cover these ones. The marker list is automatically updated. I'm just going to remove it so we can have 3 speakers detected, which is pretty cool. Now I'm going to start the tracking, and this actually creates the speaker objects which we're going to use throughout our experiment. So if you go to the next window, which is the marker speaker assignment window, this displays a mapping from the speakers to the actual channels on the sound card. Now, what I forgot to mention is that the speakers are connected to a 7.1 sound card. Now, this sound card has 8 channels, and we only have 3 speakers. So we have to know exactly which speaker maps to which channel. Now, if we see here, the first one is the wrist speaker. This is automatically added no matter where the markers are detected or not. Unfortunately, I don't have a wrist speaker at the moment, so if I test this, nothing will work. This test button for each speaker outputs some sound, making sure that that's the right channel for the specific speaker. Now, if we try marker number 1, we'll hear a sound, which is great. If we try marker number 2, sound seems to be working fine. And marker number 3, yeah, that seems to be working as well. Now, if we look at the channels, there are loads of them, but let's choose another channel and see if it's working. Nope, that channel is not right, so I'm just going to change that to what it was, and that should be it. Yeah, that should be it. So we are done with the marker speaker assignment, and we want to move on to the next phase in our experiment setup. Now, this window over here allows us to create the actual designs that we're going to be used throughout the experiment. So, for example, as you can see here, in designs, in the design section, we have chosen the pitch design. So this is the actual sound feedback. So we can change that to either Geiger, pitch, constant, or the control sound. This is the control feedback. This doesn't output any type of sound. So whereas constant outputs some sound, but it doesn't change, control doesn't output anything. So I'll just stick with pitch for the moment. And the feedback type, I can choose whether the feedback, the audio, the actual sounds come from the target speaker, the wrist, or both. I'm just going to leave it to individual. And over here we can define other conditions. So each condition holds a specific design type. Now, what I forgot to mention is that the trials are basically how many times we run through each speaker. So for example, we've had 3 speakers and trials is set to 1. That means for that condition we would have only 3 trials. But if we go to condition number 1 and we set trials to 2, then for each speaker we will go 2 times with the same sound design. We only want to go once this time, but I'm not going to go through the whole experiment. And the groups basically create different conditions. So for example, if I have this simple group, it doesn't have any conditions over here, but I can just add 3 conditions, so I can set up my own Geiger individual condition, or Geiger wrist, coalescent, and Geiger wrist. Cool, now let's move on. The next window shows some specific hand settings and setting up the participant. So in the first window, we can set the tracking type for the hand. That's basically either full hand, which tracks 22 joints, or we can set up the extremities ones, which track the closest, leftmost, and so on extremity of the hand. Hand order specifies the actual how the hand is assigned a specific ID. So basically, you can just assign it by time, or by nearest to furthest, or only assigning IDs to left hands. So I'm just going to leave it as B. And enable stabilizer is an option which allows us to remove the actual jiggers detected by the camera during the experiment. Okay, so let's start with the actual experiment, see how it goes. So we can hear the first speaker actually working, and this is the pitch design. Unfortunately, my hand is just over here on the other side, but you can hear the design changing as I get closer. And if I press brace, we just move to the next round, which is pretty good. If I want to pause the experiment at any time, I just press pause, and then after the trial has ended, so after the participant has pressed space, the experiment will be paused. Cool. So you can actually see that the pause button is disabled and the start resume one is enabled again. So let's resume our experiment. Let's see if that works. Yep, that works fine. And we just continue with the last speaker in our condition. And we move to the next speaker. Now, I'll just stop the experiment for now, as the next section will provide a rundown through the whole experiment. So you'll see me just having a wee bit of fun with the actual experiment. Cool. So thanks for watching, and I hope to enjoy the next section. See you later.
Don't forget to press for space. Is this a wrist? I'm not sure. I think it's individual. Pitch is really bad. I don't know why. It's still too far away. Is it too fast? No. It's hitting the high notes when the hand's too far away still. Okay. This is the highest now, right? Yeah. I'm gonna fix this. And that's right? Yeah. Turn off the one. Can you turn off the